Everyone, welcome to class. My name remains Engineer Shegun, and today we are going to be talking about motion. Now, simply put, a body is set to undergo motion when it changes its position from one point to another. It is important for the sake of JAMB and WAEC, and including NECO and the IGCSE, that you know the types of motion because they can test your knowledge from these categories. And there are several ways you can describe or explain motion, but motion can be generally put into these 5 categories. And they are translational motion, random motion, circular motion, rotational motion, and oscillatory motion. Now, let's now talk about each and every one of them. Translational motion. A body is said to undergo translational motion if it moves its entire mass from one point to another. For example, the motion of a man walking is a translational motion because it's moving its entire mass from one point to another point. Random motion, on the other hand, is an irregular motion of particles in various directions. Random motion is also known as Brownian motion, or you can also say it's zigzag motion. Example of random motion are the motion of dust particles or gas molecules. Circular motion. Circular motion is a very easy concept for you to wrap your mind around. A body is said to undergo circular motion if it moves around a circular path. So, a car moving around a circular path is a circular motion. The motion of the earth around the sun, or as the earth revolves around the sun, is an example of a circular motion. The motion of the moon itself around the earth is also an example of circular motion. Now, for rotational motion. Rotational motion is the spinning of a body about a fixed axis. Now, I know that there's a little bit of confusion about circular motion and rotational motion if they're exactly the same or they are slightly different. Now, they are slightly different and they are not exactly the same. For circular motion, the body is moving around a circular path, but for rotational motion, the body is spinning about a fixed axis. For example, the spinning of a fan, the orb of a fan, is a rotational motion because it's spinning about a fixed axis. If you have a bicycle, you lift the bicycle up and just roll the tire. That motion is rotational motion because it's spinning about a fixed axis. So that's for rotational motion. Then there's oscillatory motion. Oscillatory motion first is a periodic motion of bodies about a fixed axis. When I say periodic, I mean something that repeats itself at regular intervals. So I can also replace that phrase periodic motion with a to and fro motion. Example of oscillatory motion will be a simple pendulum, motion of simple pendulum, be the motion of a diverse board, or even a mass and a spring system. I should also add that simple harmonic motion is a special type of oscillatory motion. And simple harmonic motion is a topic of its own which we are going to study in our journey of physics. Now, it's also important that I say this, that a body can undergo multiple motions simultaneously. And JAMB in the past have tested this knowledge and have required students to know this. For example, there's this question that JAMB asks, the motion of a moving car. The motion of the tire of a moving car undergoes what type of motion? The options were very interesting because the options was not just one single answer. Option A was something like translational motion and rotational motion. Option B was translational motion and circular motion. Option C, let's say it was random motion and translational motion. And option D, let's say random and circular motion. But the way the question was asked, let's now look at the motion of the tire of a moving car. First, the tire is rotating, is spinning. That's rotational motion. But it is moving from one point to another. That's translational motion. So from the way the question was asked, you will see that tire is undergoing simultaneously 2 types of motion. One is rotational motion, but because that tire is also moving from one point to another, and that is also translational motion. So that car, the tire of a car, is undergoing simultaneously a rotational motion and as well as a translational motion. Now that we have discussed all the type of motion and the things that you need to know, the next thing we are going to look at in our next class will be the equations of motion and how we can answer questions with them. Welcome back. In our previous lesson, we have looked at the type of motion. Now we are not going to be looking at the equation of linear motion. And the equation of linear motion are these four. Equation 1, we have V is equals to U plus or minus AT. Equation 2, we have S is equals to UT plus or minus half AT squared. Equation 3, we have V squared is equals to U squared plus or minus 2AS. Equation 4, we have S is equal to, open a bracket, V plus U divided by 2, close bracket, T. Now, let me talk about what these letters stand for and why there is a plus and why there is a minus. Here, V stands for final velocity and U stands for initial velocity. A is acceleration or deceleration, and T is time. S is distance. Now, I just told you that V is final velocity. It can be used interchangeably with final speed. I am not saying that velocity and speed are exactly the same thing. They are not exactly the same thing, but they can be used interchangeably in some context. Velocity is a vector quantity, while speed is a scalar quantity. And we are going to look at vectors and scalars when we get to that topic. So, how does a student recognize the final velocity or the final speed? The final velocity is the velocity that the body has attained after it has covered a distance or after a certain amount of time. Initial velocity is the velocity that the body is starting with. A is acceleration or deceleration. If a body is accelerating, we are going to use plus, meaning this minus sign will not be here. And if a body is decelerating, we are going to use minus, meaning the plus sign will not be here. So this plus or minus is used, the plus sign will be used or the minus sign will be used. It's all depending on whether the body is accelerating or is decelerating. That being said, the next thing I would like to talk about is this. We should know the following. These are the tips of using these four equations of motion. Tip number 1. If a body starts from rest, U is equals to 0. U being the initial velocity or the initial speed. If a body was already moving and then decelerates to rest, V will be equals to 0. V meaning the final velocity or this final speed. If a body were to be traveling with a constant speed or a constant velocity, then A will be equals to 0. Now, let me make this very clear. If a body is traveling with a uniform speed, uniform velocity, constant speed, or constant velocity, A will be equals to 0. But if they say the body accelerates uniformly, you cannot say A is equals to 0. Accelerate uniformly is different from saying it's traveling with a uniform speed or velocity. That being said, now let's now look at the possible questions that they can ask you on this. Still on motion, we are now going to start taking questions. But remember previously that we have given this equation before, and I told you what V is. I said V is final velocity or final speed. I told you U is initial velocity or initial speed. This plus or minus. If it's accelerating, you use plus, and if decelerating, you use minus. This acceleration or deceleration, and this is time. The same goes for the second equation, where S is now the distance covered or the displacement. U initial velocity, T is time, plus or minus, accelerating plus, decelerating you use minus, half AT squared. The third one too, V is final velocity, initial velocity, acceleration or deceleration, distance or displacement. For this last equation, you will notice something that in every one of them, equation 1, there was plus or minus, equation 2, plus or minus, equation 3, plus or minus. This equation 4 is just only plus. So it simply means that it does not matter whether the body is accelerating or decelerating. If you are to use this fourth equation, it is always plus. That being said, let us take our question. Our question goes like this. A car accelerates uniformly from rest at 3 meters per second squared. Its velocity after traveling a distance of 24 meters is. The important thing you do in trying to solve this question is to set out your parameters. Parameters simply means the things that you were given in the question. So I'm going to wipe this off now so that I can set out the parameters. Now, from the question, a car accelerates uniformly from rest. It simply means that it's starting from rest. You know what I told you in the tips of using the equation of motion? I told you that if a body starts from rest, u is equals to 0. So our initial velocity is equal to 0. They give us acceleration there as 3 meters per second squared. So A is equals to 3 meters per second squared. The question said, its velocity after traveling a distance of 24 meters. That velocity they're asking us there is our final velocity. Recall, I told you that the final velocity is the velocity it will attain after it has traveled a distance or after a certain amount of time. They said, its velocity after traveling a distance of 24 meters is. So we are looking for our final velocity. Next question is, which of the equation are we going to use? Moreover, they also give us distance, which is 24 meters. Which of the equation are we going to use? Is it going to be the first? Is it going to be the second? Is it going to be the third? Or is it going to be the fourth? We are going to use the third equation, and this is why. The third equation is v squared is equal to u squared plus 2as. Notice here, I'm strictly using plus. Why plus? Because the body is accelerating. That's why I'm using plus. Hadn't the body was decelerating, I would have used minus, but it's not so. It is accelerating. I'm using plus. Why did I choose this equation? Because it is only this equation that has all of this. Initial velocity, acceleration, we are looking for final velocity, and there's distance. This equation contains all of it. I cannot use equation 1 because, of course, in equation 1, there's time, and there's no time here. I cannot use equation 2 because in equation 2, there's time, and there's no time here. I'm using the what now? This equation. Now, using this equation, I'm going to say v squared is equals to u squared. U is already equals to 0. Reason being that it's starting from rest. So 0 squared plus 2 times acceleration is 3 meters per second squared. So I'll put 3. The distance is 24. Now from here, we are going to have v squared is now equals to 0 squared is 0. If you multiply the whole of this, if you do 2 times 3 times 24, you are going to have 144 plus 144. 0 plus 144 will give you 144. So I have v squared is equals to 144. Take the square roots of both sides because I'm looking for v and not v squared. If I take the square root of both sides, I'm going to have v is equal to the square root of 144. And if you take the square root of 144, you have 12 meters per second. Our final velocity is 12 meters per second. Option C.